Whenever you see a group of data like this, the first thing you're going to want to do is to get your calculator out and enter in all the data into a list. Remember to clear out a list. You can highlight the list name, okay, like right here, and then hit clear, and then the enter key. So clear and then enter, and it wipes out the screen. All right, you want to put all, yes, there's 50 of them, 50 data values into list one. And once you do that, then do the one variable statistics function, and that will calculate some of the statistics, the ones that require more sophisticated formulas. So I'm going to enter this in. Okay, so the z-score. The z-score tells us how many standard deviations a data value falls from the mean. And it's given by this formula here. So in an example like, what is the z-score of the data value 44? In this formula, the data value would be the 44. So that would be in the place of the x. This whole problem deals with the same data. So you need to pick out the mean. That's this number here. Okay, so we're going to subtract the mean, which is 41.52. And then we're going to divide by the standard deviation. All right, well, here's the standard deviation. Divide by 6.689. All right, so you want to plug that into your calculator somehow. Be sure that you use parentheses. 44 minus 41.52 divided by 6.689. All right, so it's about 0.371. And that means that the data value 44 is about 0.371 standard deviations above the mean because it's positive. This is very close to 0.333, which is very close to a third. So if you had to plot it, it would be about a third of a standard deviation above the mean. Now let's go down to the graph. Now, if you put the mean right here in the middle, and then you add the standard deviation once, twice, 3 times. By the way, I rounded these numbers. I think I probably used 6.7 here. 44, here's 41 and a half, and here's 48. 44 would probably be about right there. And as you can see, it's about 1, 2, 3, it's about 1/3 of the way to the 1. So the z-score of 0.371 would be about right here between 0 and 1. And the data value 44 that corresponds to the 0.371 would fall between the 41.52 and the 48.2. So you really need to have this scale here if you're going to answer these questions down here about the normal distribution. Just kind of go through this. Median, your calculator will also give you. If it doesn't give it to you, then what you'd want to do is to sort your list. And then after the list is sorted, you know that you have 50 data values. So you have 25 data values on the low side, and then you've got the top 25 data values. That makes up your 50. And so the middle 2 data values would be these two right in the middle. So the 25th data value and the 26th data value, if you added those 2 data values together and divided by 2, you would get the median. So let me just kind of show you that. I did sort this list. So if we go down to the 25th and 26th data value, the 25th data value is 41, and the 26th data value is 42. And the number right between those, the midpoint of those, would be 41.5. And that is indeed what the median is. But the calculator gives that to you when you run the one variable statistics. This arrow means that it's down there a little further. There it is. median. You also want to write down the min and the max, because the min and the max are used to calculate the mid-range and the range. So there's not a whole lot that you get directly from the calculator, but the mode you can get for the calculator, because if you sort the list, and since the data values are sorted, you can kind of scroll through the list. And that's exactly what I did earlier. And I found that these 3 data values each appeared 5 times. So, and there were data values that appeared fewer than 5 times. And so these had to be the modes. The mid-range, you take these 2 numbers, 75, divide by 2. And to remember, the mean, the median, the mode, the mid-range, all of those describe the same thing, the center of the distribution. So they should all be fairly close. Maybe not the mode, because there's so many different possible data values in the range from 15 to 60. The range is just the 60 minus the 15, max minus the min. And we did this z-score here. Z-score of 55. Just going to go down here to estimate it. Well, here's 54.9. 55 is just a little bit to the right of that, so just a little bit bigger than 2. And you can see that when I actually calculated it using the formula, I got something just a little bit bigger than 2. Anytime you have a data value that's more than, and it has a z-score that's larger than 2, like this one, that means, remember that 95% of all the data fall within 2 standard deviations. And so it's only the most extreme 5% of the data that would fall outside that range, 2.5% over here and 2.5% over there. And so a lot of times in a lot of textbooks, they say that, you know, we're going to identify a data value as an unusual data value if it has a z-score that's more than 2 standard deviations above the mean or less than 2 standard deviations below the mean. So this data value of -2.5, -2, -3, -2.5 is right in the middle. The value we're looking for is somewhere between 21.5 and 28.1. In fact, directly between those 2 numbers. All right, well, here's the math for these. This one here, you can just take the z-score formula like we have up here and take the data value 55, subtract the same mean, and take that result, and then divide by the same standard deviation. If you evaluate all that, you're going to get this 2.015 number. Now these two, you can turn it around and you could say, well, with a z-score of 1.25, that's 1 1/4. Here's a z-score of 1. 1.25 is about 1/4 of the way from 1 to 2, so it's about right in here. So if you could estimate what this data value is right there, somewhere between 48.2 and 54.9, that's what this number would be. All right, now for this one, we're going to use this formula here. So we're going to take the x bar, which is the 41.52, add to that the z-score times the standard deviation. And if you evaluate all that, that's where you're going to get the 49.88, and that's where that 49.88 would fall on our scale. This one is similar. X equals x bar, 41.52, but now the z-score is negative, so -2.5 of those standard deviations. And if you evaluate that, you get this number down here. Turns out to be 24.8. -2.5 on the red scale, on the z-scale, and then on the speed miles per hour scale, you're going to get to 24.8. Okay, now all of these problems are what we did mostly related to section 12.4 on the normal curve. And it's with that normal curve that we talked about the empirical rule. And here, we started off by saying that 68% of all the data values will fall within one standard deviation of the mean. So one above and one below within one standard deviation of the middle of the mean, 68%. 95% of all the data in a normal distribution will fall within two standard deviations of the mean. And then if you go out one more, from 3 standard deviations above to 3 standard deviations below, in a normal curve, all but 0.3% of the data will fall within 3 standard deviations of the mean. All right, so this first one here, these first 3 here all get at these numbers. And so let's just go through them. 68% of the data values fall between, well, 68% fall within 1 standard deviation from the mean. And if you look at the scale numbers, well, that means that the miles per hour have to fall between 34.8 and 48.2. And so that's what we put here. Again, I rounded these numbers because I rounded the standard deviation off to 6.7, I think. All right, the next one, it talks about 95% of the data values would fall within 2 standard deviations of the mean. So on the miles per hour scale, it would go from 28.1, -2, to 54.9, +2. From 28.1 to 54.9. So all of these numbers are coming from this horizontal scale down here. And then we just go, one more standard deviation out. 99.7 fall between 3 standard deviations. So we go in this range, we're going to go from this 21.5 to the 61.6. And I didn't write it here, but these are all horizontal scale values, so they're all miles per hour. We tried to figure out what percentage of all of the data would fall in each one of these slices here. And the first one is not too bad. Because of symmetry, since we know that 68% fall within 1 standard deviation of the mean, then if we split this range in half, then you would get 34% here and 34% here. And I don't know if you remember the other ones. I'm just going to give them to you. If you subtract 95 and 68, you get 27. And then you'd have to split the 27% up into these 2 slices. So half of 27 would be 13.5. So now if you add these 4 percentages from -2 to 2, these 2 add up to 47.5, and these 2 add up to 47.5. And when we add those 2 together, you get the 95. Going out further, must be 2.35% here and 2.35% here, because within 3 standard deviations, those 6 percentages have to add up to 99.7. And that leaves just 0.3% on the most extreme part of this curve. If you divide that in half, you get 0.15 over here and 0.15% over there. Okay, now let's go to this one here. 50% of the data fall above. Okay, well, right here is the halfway point. So 50% is over here and 50% of the data fall over here. So when it says 50% of the data falls above, it must be that value right there, 41.52. If you add 34%, 13.5%, 2.35%, and 0.15%, those 4 numbers will add up to 50% of the data. Okay, next one. 84% of the data values fall below. All right, so most of the data fall below what? 84% falls below what? Well, we know that on this half over here, that's 50%. And then in this one slice right here, that's 34%. So if you add the 50% and the 34%, from here down adds up to 84%. The 34% here and then the 50 there. So 84% of the data values fall below 48.2 miles per hour. And then finally, this one here, 97.5% of the data fall above right here. Okay. Because if you look over here, you get 97.5%. And over here, you're just going to add these two numbers together, and that's 2.5%. Well, maybe that's the easier way to do it. Calculate how much is to the left, 2.5%, by adding those two percentages. And 100% minus 2.5% would be 97.5% over here. So 97.5% of the data fall above 28.1 right here. So there's really no calculations that you're doing to determine these last ones. It's just a matter of finding the mean and the standard deviation. Most of the problems that you'll encounter, the mean and the standard deviation will be a lot simpler numbers. But in this case, they were messy numbers. Well, we used what they give us. And that created this scale. But for the normal curve, it's always 34%, 34%, 13.5, 13.5, 2.35, 2.35%, and so on. Those percentages will always be the same, even though this horizontal scale may change for different contexts.